Hello students, hearty greetings. We are going to discuss the important points and tips in the exam oriented way. It is very important not only you know the answer, but how to present the answer is very important. And for short answer question you have to be very precise. You have to cover the key points in long answer question and you have to mark the diagram very well. These are the important characteristics you have to remember as respect to physics. I am going to discuss chapter wise the important questions and the way to answer the questions and also solve some problems. This will enable you to get very good marks. So you can take this as a physics in a nutshell, so that you can do the quick revision based on these questions. So you will be better prepared for the exam. Okay, let us begin with the first unit, electrostatics. According to the blueprint, we have in this topic knowledge based MCQ, multiple choice question 1, very short answer 1, understanding type, short answer 1, long answer 1, and application, very short answer 1. So this is the way you are going to expect the questions. This topic consists of subtopics: electric charges and electric field, electric potential, Gauss theorem, electrostatic induction. Very short answer. This is the 2 marks definition type questions. In this type of questions you have to use the exact precise textbooks wordings. What are the topics under this? Electrostatics, what is electrostatics, what is frictional electricity? There are 2 kinds of charges, you have to give example. Conductors and insulators, force of attraction and repulsion, quantization of charges, conservation of charges, additive nature of charges, properties of charges, Coulomb's law, relative permittivity, Coulomb, definition of 1 Coulomb, point charge, electric field intensity, electric lines of force. So these are the topics, and with the dipole we have electric dipole. All these are definitions: electric dipole moment, working of microwave oven. This is an application oriented, you get application oriented questions wherever possible. So this is an application oriented topic, working of microwave oven, electric potential at a point, equipotential surface, electrostatic induction, capacitance of a capacitor, definition of Farad, dielectric polarization, polar and non-polar molecules, applications of capacitors, and corona discharge. Okay. So in the very short answer, how you will prepare? You have to prepare exact definition type, mark it in the textbook and try to write verbatim as a definition. For example, if you take Coulomb's law is the force of repulsion or attraction between 2 charges. The direction of the force is the direction along the line joining the forces. The magnitude of the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. This is the statement for Coulomb's law. So try to learn under the topics I have given earlier all the important definitions. Okay. Now we will discuss the short answer type. State Coulomb's law and explain its vector form. Vector form means very important, you have to indicate the direction. You have to indicate the direction. You have to give the force as the vector product, F proportional to Q1 Q2 by D square, R unit vector, where R square, R unit vector, where R unit vector is the unit vector along the line joining the 2 charges. You have to mention each term. You have to say what is Q1, what is Q2, what is R magnitude, what is the R unit vector. So whenever you give the law, and you have to give it in the formula form, and when you give in the formula form, you give correct explanation for each term you are using. Don't take for granted, because Unless your answer is complete, you cannot get full marks. Principle of superposition. That is, at a time many charges can react with each other, interact with each other, and the net electric force is the sum of the forces, vector sum of the forces, because force is a vector quantity. Properties of electric lines of force, you have to illustrate by the sketch. That is, if it is a positive charges, the lines of force emanate from positive charges, converge to negative charges. This is the type of force between a positive and a negative charge, and that is between two positive charges. So when you are giving the properties of lines of force, you have to illustrate by the diagram. Electric field due to a point charge, again you have to mark a point charge. And how do you measure the electric field? By a force on a unit positive charge placed at that given point. So you have to mark a unit positive charge at the given point, and very important, you must mark the direction of the force. Electric potential energy of a dipole in an electric field, electrostatic potential energy of a system of two charges. Everywhere you have to give the small sketch on base of which you are going to explain your answer. So you have to say, let Q1, Q2 be two charges, then you must mark in your diagram Q1 and Q2. Gauss law, expression for electric field be due to two parallel charge sheets. This is the two parallel charged sheets having charge density plus sigma and minus sigma. E1 is the electric field due to the positive plate. E2 is the electric field due to the negative plate. We have marked at a point P1 inside the between the two plates, that is the inside point, and P2 another point outside. You mark the, how do you measure the electric field? By force experienced by a unit positive charge placed at that point. Okay. So here at P1, imagine a unit positive charge, then the positive plate will repel the charge. So we are marked E1 outwards, whereas E2, that is due to negative charge, the negative charge will attract. Therefore both E1 and E2 point in the same direction. Okay. So that direction is very important. If you give an explanation without direction, no marks will be given to you. Similarly, for the point P2 outside, we mark E1 due to the positive plate going to the right side because it is repulsion. E2, the force due to the negative plate towards the plate. Because both are equal and opposite, they will cancel each other, and here it will add each other. So the key point in this is the diagram, the direction of forces. Okay, because the whole explanation is based on the diagram and the direction of forces. Principle of a capacitor. Capacitance of parallel plate capacitor without dielectric slab and then without dielectric slab. You can be asked both, either this or that. So everywhere you mark the diagram, and based on the diagram you explain the answer. Energy stored in a capacitor, capacitors in series and parallel.